The second topic we want to do today, and I'm trying to keep these files short, so that's why we have different ones. There'll be one more after this. We're going to talk about polyatomics because we need to understand how to make ionic compounds, and they can be metal and nonmetal, or metal and a polyatomic. And a polyatomic is just a group of atoms with an overall charge. So we are going to be learning a bunch of polyatomics this year, and if you go over to the side counter by the windows, you will see that I've photocopied the list of polyatomics that you need to know, and I've also made a packet of index cards for everyone to use. So when you pick up the polyatomics, please note that the pink cards should be used for the polyatomic cations. The blue cards should be used for the -1 charged anions, the yellow cards for the -2 charged anions, the green cards for the -3 charged anions, and the purple for the common names. So I have taped the sheet with those colors on it by the cards when you pick them up, so make sure that you use those because I've counted them out, and you only have that number. So a lot of people do not like learning the names of the polyatomics, but I hope I can present them in a way that they will not seem like so much memorization, but more of an understanding of how we're getting those names and the relationship between the different polyatomics. So the first thing is that anything that ends in ATE is going to have one more oxygen than anything that ends in ite. So let's take a look as an example. So if we look at nitrate, and nitrate is going to be NO3 minus 1, then I know that if I have nitrite, I'm going to have NO2 minus 1. Notice it's just the number of oxygens that changes, but the sign stays the same. And another family that this would be similar would be sulfate. That would be SO4 minus 2. And then sulfite would be SO3 minus 2. So if you know the 8, then you know the ite. Other ones that you need to know are carbonate, CO3 minus 2. But there is no carbonite. Instead, we have something that is a hydrogen. So hydrogen carbonate. And so anytime we're adding a hydrogen, we're assuming it is a +1. So if I add a +1 to a -2, then I end up with an overall -1 charge. Hydrogen carbonate can also be called bicarbonate. So when I'm looking at something like phosphate, that's PO4 minus 3, I know that the phosphite is just one less oxygen, but I can add a hydrogen in front of that and make that hydrogen phosphate, and I can also add 2 hydrogens in front of that and make that dihydrogen phosphate. And notice every time I add a hydrogen, it's going down by 1. 1 hydrogen goes to -2, 2 hydrogens goes to -1. The same is true for the phosphate. So HPO3 minus 2, H2PO4. Sorry, that would be a 3, phosphate minus 1. So I know phosphate, I know hydrogen phosphate, I know dihydrogen phosphate, I know phosphite, hydrogen phosphite, and dihydrogen phosphite. So all I really needed to know was just this one, and I know the entire family. So if you understand those relationships, it makes it a lot easier to understand how to name things. So the thing that's difficult is that the eights have different numbers of oxygen. So there's a little mnemonic that I think helps a little bit to try to figure that out. So if I have carbon, nitrogen, oxygen, chlorine, I'm just copying this part of the periodic table. And you should be able to find exactly where I am on the table. So there's the periodic table, just a 4x4 of that. But what is easiest is that I have this inner square like that. And then the inner box, the eights, those compound that ends in eights, have 4 oxygens. So phosphate, sulfate, arsenate, selenate. Then the outer box, this box here, the eights have 3 oxygens. So it's kind of an easier little mnemonic to figure out which ones have 3s and which ones have 4s. So let's just take a look at an example. So if I have ClO3 minus, I have chlor 8. If I have ClO2 minus 1, then I have chlorite. If I add one more oxygen, the charge stays the same, but it has a different name. That is perchlorate. And if I go down one more oxygen, that is hypochlorite. So all I really need to know is the chlorate, and I know all of that family there. But the chlorate is similar to the bromate, which is similar to the iodate. So if you know the chlorate, the bromate, the iodate, then you know all 12 of these, and they are on the chart as -1. So those are not as onerous to remember if you understand the relationships. Lastly, we have 2 polyatomic cations. The first one is ammonium. Not to be confused with ammonia, which is a neutral compound. So don't confuse it with that. Then the other one that we have is Hg2 plus 2, and that is mercury 1. And that should not be confused with mercury 2, which is Hg plus 2. Okay, so those are all the polyatomics, and you need to memorize them. So take some time and make those cards in class today.